Good morning, students. Welcome to the session. In last video, I gave the notes for the lesson 3 from the acids and bases lessons. Did you complete the notes? So, I have information that you are not completing your classworks and you are not listening the videos and simply you are enjoying by playing games and watching TV and something. Just you are spending time instead of studying and writing. See, complete your works and be update when school starts. We'll give the marks and we'll do the corrections. Then at that time you cannot complete your works and it is very difficult to you. It is very difficult to you. So complete your works and be ready. Okay, now I'm going to start about the fourth lesson in this video. Light travels always in straight line. Light always travels in straight line. And light has some properties that in 9th class you learned about reflection and the refraction. A reflection of light at curved surfaces and reflection of light at plane surfaces, that we discussed. And in the 9th class, you discussed about the refraction of light at plane surfaces. First, we'll recall about what is reflection and what is refraction. What is reflection of light? When light travels falls on any object, it bounces back. So bouncing back of light rays is known as reflection of light. That we discussed at plane surfaces and curved surfaces. And refraction. What is refraction? Light rays, in the reflection of light always travels only in particular medium. Only one particular medium, either air medium or otherwise a glass medium or otherwise water medium. Only particular medium it travels, and in that medium only it bounces back. Means reflection of light takes place in only one medium. But coming to the refraction of light, the light rays travels two mediums. From air to water medium, or water to glass medium, or glass to water medium. Like that it travels light. So when the light travels from one medium to the other medium, the speed of the light changes. When the speed of the light changes at the interface where the two mediums are separated, at that interface it bends and travel. So the bending of the light ray is known as refraction of light. That is known as refraction of light. So this refraction of light will discuss at curved surfaces in our topic. So lesson 4 is the refraction of light at curved surfaces. Here you see the refraction of light at curved surfaces. Can you give examples of the refraction of light? When you place a lemon in a glass of water, you can find out the size of the lemon. When you observe the lemon from the outside of that glass, you can see bigger in the size. And at the same time, you take either a pencil or anything scale and just you place it, put it in the water, which can say a glass of water. And if you find out where the interface is there the pencil bends. Pencil bends. You cannot get here. You can get the straight line, but in where you put that pencil in the water, it bends. That you cannot get that straight line. And the stars are twinkling. These are all the examples of refraction of light. Now, one more example I will explain. To explain this, for the refraction of light, I have to do a small activity. For this, just I'm taking one paper and I drew an arrow. Okay, and you find out the head of the arrow is on which side. Here this head of the arrow is on my right side. Now we'll find out the image of this arrow through a glass tumbler which is having the curved surface. Now I'm taking a glass jar. You can take glass, curved glass, any you can take, but I have this jar. So just you observe the image of this arrow through. Here I'm placing this end and you observe from the other end. And what type of image that you can see, just you observe. So when you find out the image of this arrow, that you can find out diminished image. Can you see that? I'm trying. If you cannot see, try, you do at home and find out. So that you can see that a diminished image is formed when you observe the image of this arrow. You place it to one side, and when you find out the image from the other side, when you see from the other side, that you can see the image of this arrow is diminished. Okay, this is the activity 1. Why? Actually it is larger, the arrow is a little larger, but the image when you are finding through the glass jar, you can get a diminished, means small image. Why? What is the reason? I'll tell you later. Now in this glass jar, here what is there? Nothing is there, means air is there, means here the light rays that traveling from the glass to the air and from air to the glass, like that they are traveling. While they're traveling, we'll get the image, diminished image. Now in this glass jar for activity 2, I'll fill with water. Now I filled with water, then we'll find out. And you see that what type of image that you can see. When the glass jar is empty, you get a diminished image. Now if you fill with the glass jar with water, and what type of image that you are getting, and carefully you observe the head of the arrow. Here the head of the arrow is on my right side, and see, and here through water the head of the arrow is on which side, just you find out. The arrow is on left side. Why? And it is an invert image. When you observe the same arrow through water medium from the glass jar and water, you are getting that the reverse image, invert image. Why there is a change? In the case 1, you are getting a diminished image, and in the case 2, you are getting the invert image. Why there is a change in the images? This is, in these 2 cases, the refraction of light takes place. Due to that, we are getting the image diminished, and in the second case, inverted image. So to explain through the ray diagrams how the refraction takes place in the activity 1 and in activity 2, I will explain through the diagrams. Here there are 2 mediums are there. What are the 2 mediums? When you take the glass jar, when you place this arrow, the light travels from the glass medium. In the case 1, glass medium to air medium. Glass medium to air medium, and again from the air medium to glass medium. So like that, refraction takes place at the 2 curved surfaces. This is one curved surface and this is another curved surface. At these 2 curved surfaces, the refraction takes place. Due to that reason, we got the image like diminished in the first case. And in the second case, the jar is filled with water. So the light rays traveled through glass medium to the water medium. Again from the water medium to the glass medium. And from glass medium to the air medium. Like that, different medium. The light rays are traveling in different mediums. Due to that reason, we'll get the image, that is the invert image. So through the diagrams, I will explain this. Here the refraction of light at curved surfaces. Now, what is the definition of the refraction? Bending of the light ray is known as when it travels from one medium to other medium, it's the speed of the light is changes. Due to that reason, it bends and travels. This is known as the refraction of light. For the reflection of light, it requires only one medium. It requires only one medium. There is no chance of bending. The reflected ray and the incident ray and the reflected ray, it takes only in one medium. But in the refraction of light, the incident ray in one medium and the refracted ray will get in another medium. Due to that, the light rays bends, they change. The light rays changes the direction and travel. But while they're traveling in mediums, always they travel in the straight line only. But where the interface is there, interface means where the two mediums are separated, from that interface there is a bending of the light rays. This phenomenon is known as refraction of light. Now, case 1. Here I said about the curved surfaces. And in the first lesson we discussed about the curved surfaces are of two types, convex and concave. So now, suppose how does the refraction of light takes place for a convex mirror. Here we'll take the two mediums. What are the two mediums? Air medium is there, water medium is there, glass medium is there. So air medium and water medium, the refractive indices of these two mediums will consider as same. Actually they're not same, but we'll take it as same. Approximately the values are equal. And glass medium, or otherwise leave about all these mediums. We'll take the two mediums, rarer medium and denser medium. Rarer medium means the particles are very less, and denser medium means the particles are more. So here we'll discuss about the case 1 for a convex mirror. When a light ray travels from the rarer medium to denser medium. Here what are rarer and denser? A rarer medium means the density of the particles are very less. Whatever air particles, whatever may be, the density of the particles are very less. Denser medium means the density of the particles are more. Now you take one convex mirror and you draw the principal axis. So for the principal axis, it is the pole and this is the center of curvature. Suppose if a light ray travels from a light ray which is parallel to the principal axis is traveling from a curved surface. For a curved surface means from a rarer, here it will take it as air medium, to denser medium, either you take it as water medium. Through the glass, if it travels through the water medium, denser medium, how does the refraction takes place? So to find out, always we have to draw a normal. So here how to draw a normal for the curved mirrors? Always we have to draw a line from the C to this where this incident ray is touching on the mirror, curved surface. So here you have to draw a normal. This is the normal. And while light ray is traveling from the rarer to denser, the refracted, this is the incident ray. And it is traveling from air to the water medium, or otherwise from glass to the water medium. Here the ray travels here denser towards the normal. Once again I am repeating, when a light ray travels from the rarer medium to the denser medium, when a light ray is parallel to the principal axis and it travels from the rarer to denser, it moves towards the normal. The refracted ray bends. The refracted ray bends towards the normal. When it bends towards the normal and the refracted ray travels and where it touches on the principal axis, there you will get the focal point. There you will get the focal point. Now, here the light ray is traveled from the rarer to denser. For example, if you take the light ray, if it travel from denser medium to rarer medium, denser medium to rarer medium. So here this is the center, a ray which is parallel to the principal axis from the denser to rarer. So to find out the refraction, the refracted ray, again you have to draw a normal. To this normal, from denser to rarer means the density is very less than compared to the denser medium. So due to that reason, the refracted ray moves away from the normal, means like this it travels. It moves away from the normal. Here there is a difference between the rarer to denser, denser to rarer. From the rarer to denser, then it bends towards the normal. But here from the denser to rarer, it bends away from the normal. And when you find out the, here this refracted ray is not touching on the principal axis. But when you extend this refracted ray from the other side, it will touch on the principal axis. Where it touches on the principal axis, there you will get the focal point. So this is the focal point. And in these two cases, this reflection of loss of reflection are valid. What are the loss of reflection? Angle of I is equals to angle of R. So is that angle of I is equals to angle of R for this refracted rays? From, see here, angle of I and this is the angle of R. And here for the denser medium, angle of I and this is the angle of R. So in these two cases, for the refraction phenomenon, angle of I is not equals to angle of R. Depends on the medium. One is greater than the other, but they are not equal. Like a reflection of light, in the refraction of light, this angle of I is not equals to angle of R. Here when you compare this, here angle of I is greater than angle of R. But here when you compare this, angle of I is less than angle of R. Now, in the second case, here we are discussing about the refraction of light on curved surfaces. So curved surfaces means we have the convex and concave. Just I discussed about the convex. Now I will explain through concave surface. For this, just you take a 1 minute. So this is, suppose here this is the rarer medium and this is the denser medium. First always we'll take from the rarer to second medium is denser, and here from the denser to rarer medium. And now when a light ray is parallel to the principal axis, when it travels from the rarer to denser medium, always you must draw the normal. So this is the normal. This is the normal. So from rarer to denser means its speed decreases. Its speed, because density is more, its speed is decreases. So decreases means what happens? It moves towards the normal. It moves towards the normal like this. Here angle of I, and this is the angle of refracted ray. This is the angle of incident. And here the refracted ray is not meeting on the principal axis. So when you extend this, it meet at one point on the principal axis. Where it touches on the principal axis, that point we'll call it as the focal point. Now one more. Here I took as the rarer to the denser. Now I'll take for the concave mirror for denser medium to the rarer medium. See, this is the denser medium and this is the rarer medium. This is the medium 1 and this is the medium 2. So here also, when here we'll take it as center of curvature. When a ray is parallel to the principal axis and the incident ray is in the denser medium and the refracted ray should pass through the rarer medium. So for that, again you have to draw a normal. When a light ray travels denser to rarer, its speed is increases. Its speed is increases. Rarer to denser means its speed is decreases, but denser to rarer means its speed is increases. So here denser to rarer means its speed is increases and it's move away from the normal. So instead of that, it moves away like this. The refracted ray, it moves away like this and it touches at one point on the principal axis. Where it touches, that we'll call it as the refracted ray. Where it touches on the principal axis, that we'll call it as the focal point. Once again, I'm repeating, whatever the type of the mirror, whether it is a convex or the concave, when for the refraction of light, it should travel through two different mediums. So that whatever water, air, glass, whatever the mediums, that will considered as two mediums, rarer medium and denser medium. So rarer medium, the density of the particles are very less, and in the denser. Rarer medium, the density of the particles are very less, and in that rarer medium, the speed of the light is more. And if you take in the denser medium, the density of the particles are more and the speed of the light is decreases, is slow. So that's why while you are finding from the rarer to denser or denser to rarer, whatever the type of the mirror, we have to find out. So rarer to denser means its speed decreases. When its speed decreases, the refracted ray travels towards the normal. The refracted ray travels towards the normal. From rarer to denser. Here also rarer to denser. The refracted ray travels towards the normal. Next, denser to rarer. Denser means here the particles are more. From the heavier particles to lighter particle, the light ray is traveling from denser to rarer means the speed increases. When the speed increases, the refracted ray travels away from the normal. So that's why the refracted ray in the rarer medium away from the normal. And here also to this normal, the refracted ray is away from the normal. So this is the principle and the refraction of light.